In this recitation, you'll learn about some techniques to preprocess and augment audio data. We'll be using Torch Audio, Matplotlib, IPython, and librosa in this recitation. Torch Audio provides convenience to loading audio datasets, transforming and augmenting the audio data. LibreSpeech is a labeled speech dataset that you will encounter in several homeworks. We'll use an unpreprocessed version of it to give you better understanding of this type of data. To download, we will simply create an instance of LibreSpeech like limited dataset provided by Torch Audio. The data in this dataset is organized as a tuple of waveform, sample rate, transcript, speaker ID, chapter ID, and utterance ID. We'll use waveform, sample rate, and transcript in this tutorial. For the first data sample in this dataset, it has 175,000 frames with a sample rate of 16,000. This gives us a recording of around 11 seconds. Now here's a visualization to the raw waveform. We can also use IPython library to play this audio in the notebook.
Permission to accept such additional employment, should it offer, having formed an article of the terms on which he had engaged me. It was therefore arranged in the course of next day.
To enhance our data, we usually extract the features of waveform using MFCC coefficients. You may learn more about MFCC by yourself, but the intuition behind this data format is not covered in this course. Here we use Torch Audio to transform waveform to MFCC data. The extracted data now have 27 features for each time steps, and here is the visualization. Now we'll talk about data augmentation. Before that, it is recommended to first normalize the MFCC data, and you will have to implement it by yourself in homework 1. One of the most efficient and useful technique is called spec augmentation, which consists of either or both of frequency masking and time masking. To perform frequency masking, we'll use frequency masking transformation provided by Torch Audio. The first parameter is the maximum length of frequency that will be masked. We have set it to 10, but it will require you to perform many applications to find the best value. After the masking, you can see that some part of the frequency range is masked and left to blank. Time masking is similar to frequency masking. You just have to call time masking function provided by Torch Audio. The first parameter is the same, which is the maximum length of time that is allowed to be masked. Now, by the visualization, nearly 200 time steps are masked.